So good morning, grade 12 students. In this session, we're going to continue with the nervous system, chapter 9, the function of neurons. So first, we finish about the document 1, about the resting potential. We determined the resting potential, which is equal to minus 70. Also determined the polarity of the membrane. It's negatively charged due to the differences in the selectivity of the membrane to the K plus and Na plus through their pumps, K plus and A plus pumps. And also we talk about how do we maintain the resting potential due to the action of what's known by Na plus K plus ATPs or Na plus K plus pump. We knew that the source of energy or the energy is used in the form of ATP, adenosine triphosphate. Also, we determined the action of dinitrophenol. It inhibits the phosphorylation of the ADP. We studied these note that diffusion is the movement of a substance from a medium of high concentration, the high pressure or high volume to a medium of low concentration, low pressure, low volume. And passive and active transport, we determine the differences between them. We said that the active transport is the transport that takes place against. It needs energy, while the passive transport is the one that takes place with the concentration gradient and it doesn't need energy. Also, we said that the ATP, adenosine triphosphate, is the source of energy which is used by the cell. We said that the ADP, upon phosphorylation, becomes ATP, which is the source of energy, and ATP upon the dephosphorylation, so we remove phosphated group, it becomes ADP. We move to second document 2, about the action potential. We determine the different phases of the action potential, including the resting potential, the hypopolarization, and also we talk about the depolarization, about the repolarization, about the hyperpolarization, and then moving back to the resting state. And also we determine the different, let's say, number of active or open channels as for K plus and Na plus in this graph. Now I'm going to move to document 3, talking about the nerve impulse and the action potential on page 187 on your book. So we started this yesterday about the nerve impulse and the action potential. We started about the characteristic of the nerve impulse in paragraph 1 in the nerve fiber. So we said that we have isolated nerve fiber is subjected to stimulation. These stimulation, they are of increasing intensity, I1, I2, and I3. They are below the threshold, whereas I4 and 5 and 6, they are above the threshold. That's why we can see that I1, I2, and I3, they are said to be ineffective stimulation since they are below the threshold of depolarization, whereas the I4, I5, and I6, they cause the appearance of the action potential as shown here. So this is referred to the effective stimulation, whereas I4 is the first stimulation to cause an action potential. So it's referred to the threshold of excitation. Moving to the second document, document B, that we are going to interpret it in the coming slides. So in the second experiment, the nerve fiber is subjected to only one stimulation of an intensity above the threshold. The response is recorded by 3 oscilloscopes with recording electrodes that are placed at different distances from the stimulating electrodes. So here we have the stimulating electrodes. So here we have different recording electrodes. Recording electrode 1, 2, and 3. They are located at different positions. So the distance between them, it's the distance here. We have the D, it's 1 centimeter, and at the time here, it's 1 millisecond. For example, if I want to calculate the velocity of the propagation of the nervous muscle, what is the rule? V is equal to what? Anyone can give me this formula? This is a physics formula, and already we mentioned this in the introduction for the nervous system. If I want to calculate the velocity or the speed, it's what?
D over T.
Yes, it's delta D, distance over the time, delta T. So here, D, we have it what? We have it 1 centimeter. So in order to convert it into meter, what do we do? Okay, let's see your physics abilities.
10 power minus 2.
That's very good. So it's 10 to the power minus 2 times 1. So it's 10 to the power minus 2 over, this is in meter, sure. Over time, it's in millisecond. So in millisecond, it's what? It's 10 to the power minus 3. 10 to the power minus 3 seconds. So it will be 10 meter per seconds. So here is the velocity or the speed of propagation of the nervous message if they want you to calculate this. So here, as you know, in the speed, it's the speed of propagation of the nervous message. First of all, let's observe here the three oscilloscopes, 1, 2, and the 3, recording the action potentials. If you see here, all of them, they have what? Of them, they have the same amplitude. All of them, they have the same amplitude, meaning that the propagation of the nervous message is coded by what? Or the nervous message in the nerve fiber is coded by the, not by the amplitude. Since all of them, they have the same amplitude, but it's coded by a different property. And we are going to identify it in the coming slides. So here, all of them, they have the same amplitude. Moving down to paragraph 2, talking about the characteristics of the nerve impulse in a nerve. A nerve is made of different type of axons. These axons, maybe they are myelinated, meaning that they have the myelin shaft, which is acting as a lipoprotein and is as a insulator that protects and that isolates the axon, and it allows a faster and it accelerates the propagation of the nervous message to what it's going to move in a saltatory movement, if you remember this, or non-myelinated axons. These non-myelinated axons, sure, the speed will be lower than the normal. So these are the myelinated axons containing the myelin shaft, which is the lipoprotein, and these are the non-myelinated axons, and these. So here, the nerve carries the nerve impulse at different velocities. This is going to be shown in document D. In the body, the non-myelinated fibers are twice as much as the myelinated. So let's move now to talk about this. In this document D, they are showing the variation of the speed conduction or propagation of a neural impulse in certain nerve fibers. So here we have fibers of a neuromuscular spindle. Also, we have mechanoreceptors of the skin. Third, we have the deep muscle receptors. They are the sensitive, and the fibers of pain receptors. Okay, and we have here the giant axon of the squid. Let's see here, if we have myelin, what will happen to the speed, and if we don't have myelin, what will happen. First of all, this is the myelin. Plus, it means presence. Minus, it means absence. Here they are giving the average speed of propagation of the nerve message in meter per second, and also they are giving the average diameter of the nerve fibers in micrometer. First of all, when the average diameter was 13 micrometer, and we have myelin. What is the speed? The speed is about 75 meter per second. So we have large diameter, if you want to say, large diameter, and we have a myelin. So this speed is very high speed. While moving to the mechanoreceptors of the skin, the mechanoreceptors, the average diameter is about what? About 9. And there we have myelin. So the speed becomes 55. So Selena, what do you think about this? The first one, the average diameter was 13. We have myelin, so the average speed was 75. While in the second one, with the mechanoreceptor of the skin, the average diameter, it was 9. And we have myelin, so the speed decreases to 55. So what can you conclude from this?
That the diameter affects the speed of propagation.
First of all, we have the first factor, very good, Selena. So first factor is that the diameter affects the propagation of the nerve impulse or the nervous message. And whenever we have a large diameter, so as the diameter increases, the nervous message will increase. Moving to the second, or the third. The muscle receptors, they are sensitive to the pressures. So these, we have the diameter is equal to what? The myelin do we have or not? And what is about the average speed? Let's move to Hassan. Yalla Hassan. Deep muscle receptor fiber, they are sensitive for pressure. What is the value of the average diameter? Yes, Hassan, what one?
Can you repeat the question?
Yes, Hassan. We are talking in the third one. I'm going to put it in another color. Let's say I'm going to put it in a blue. And this one. Okay? So here, what is the value? What can you say about the diameter? What can you say about the myelin? And what can you say about the speed? The average diameter is equal to what?
3
micrometer. Very good. And do we have myelin or not?
the
Myelin is
average
present.
speed.
Myelin is present or not? Do we have myelin or not?
Yes,
So we have myelin. And what is the speed? The value of the speed?
11.
What? 11 meter per second. So what happened here? We have myelin, but what is the difference? What is the variable? It's the value of the diameter. So when the diameter decreases to 3 micrometer, the average speed it decreases to 11. Okay? So here is another indication about the action of the diameter. Let's move now to the fourth one, which is talking about the fibers of pain receptors. Let's move now to Rama. What do you think? Fibers of the pain receptors, which is this one. Fibers of the pain receptors. What can you think about this, Rama? Rama maybe has a problem with connection. Let's move to another. Samar, good morning. Good morning, Samar. Okay, great. So let's move to another one. Let's move to Muhammad. Yalla, Muhammad. So fibers of pain receptors. What can you think about the fibers of the
Yes.
pain receptors? What happened to the myelin? What about the diameter? And what can you say about the average speed?
You want نحن we reached the last one, right?
لا,
خلصنا
fibers
الفيديو.
of pain receptors. The one with
بعدين
the
the average diameter was 0.5 and the speed of
micrometer.
propagation was 1. Yes, but
Micrometer.
this is caused by the absence of myelin.
So we have myelin, no myelin,
Speed of propagation.
absence of myelin. Very good. And we have small diameter. So both of them,
Yes.
they affect the speed to reach about 1 micrometer. So here, the myelin has a high effect on the speed of propagation. Also, whenever we move to the giant action of its width, we have the average diameter was 700. Even though the average diameter was 700, but we don't have myelin, so it's about 25. Meaning that less than that when the maximum is the average diameter was 13, and we have myelin. So myelin has a high effect on the propagation of the nervous message. So both factors that affect the propagation of the nervous message in this activity, they are diameter of the nerve fiber and also the presence of myelin shaft. Moving now to the paragraph talking about document E1 and 2. Pay attention to this. Using the same setup that's used in document A, there's the simulating electrodes and the connecting them to the oscilloscope. Stimulation of increasing intensities are applied on a nerve. The recordings are obtained by oscilloscope O1 and represented on document E. So we have representation of these recordings and increasing intensities, and here they are recorded at different instances. Pay attention here. You're talking in what? In a nerve or nerve fiber. Here they are talking inside a nerve. So pay attention here. Nerve. What is the difference between the nerve and nerve fiber? Nerve fiber obeys the law of all or none. Remember this. So the nerve fiber, it obeys the law of all or none. Let's move. In the second experiment, the stimulation of intensity above the threshold was applied. The recording electrode R1 is displaced on the nerve in such a way that each time we change the distance to the stimulating electrodes. So they separate the distances between the recording and the stimulating electrodes. The obtained traces are shown in document E, and this document E part 2, not part 1. But let's start first with document E part 1. Document E, they said they apply stimulation of increasing intensity. I1, I2, and I3, I4, I5, and then 6. So this amplitude is about 100 millivolt. This is the maximum. So if you want to move, you will have differences somehow between them. Okay? So we have differences. So here, they are not all of them, they are the same. But first, what is the first one to cause an action potential? Which is the first intensity that causes an action potential? What do we call it? Yes. What do we call the first one that causes this, Muhammad? What do we call the first
Threshold
one?
of excitation.
Threshold of excitation. Called the threshold of excitation. Very good. But here I2, they are called ineffective stimulation since they don't cause the appearance of an action potential. I3, 4, 5, 6, they are called effective. They cause the appearance of the action potential. But the most important part is here. Here we are talking about nerve. So here the distance between the S2 and R1, the stimulating electrode and the recording electrode, in millimeter. First, it was 15. How many action potential do we get when the distance between them? It was 15. How many action potential did we record? When the distance between S2 and R1, it was 15. How many action potential did we record here? As you see, one action potential is recorded. So only one action potential is recorded. While when we increase the distance from 15 to about 110 millimeter, what happened? We have here is an action potential, and here is another one, another action potential. So here we have two action potentials. Approximately, if you want to say two action potentials. So if we want to talk about this, first of all, the time needed for the first one when the distance was 15 millimeter, the time needed is about what? After the stimulation is about 1 millisecond to cause an action potential. While after the distance is increased from 15 to 110, it needs about 3 milliseconds to cause an action potential, to have an action potential. So first of all, you have to know the following. When the distance increases, this means that the speed of the action potential of the propagation of the nervous muscle story will decrease, and it will take more time to have an action potential. Why? Why? Can you give a logical explanation for this? Why? Why do we have differences in such a nervous message or propagation of a nervous message? Why do we have such a difference? Yeah, let's say
The speed
yes.
of propagation depends on the diameter and the time.
Okay, first of all, it depends on the diameter. Maybe they have different diameters. The nerve fibers, they have different diameter inside this nerve. So we have different diameters. First of all, this is first note. This is first logical reasoning. Can you give me, Hassan Watfa, another logical reasoning? Ali Muhammad first, that means maybe they have different diameters. Second note, what do they have? Maybe. If they have different diameters, other than the diameter that affect the speed of propagation, maybe they
They
have,
conduct
yes?
they conduct the message slower.
They conduct the message slower. Why? Due to what? You have some factors that affect the speed of propagation. We have diameter first.
Maybe non-mile.
Non-myelinated. Very good. So non-myelinated, maybe they lack the myelin. So maybe they have myelinated and non-myelinated nerve fiber. That's why it affects the propagation of the nervous message. So these, they are mentioned in part one. They want you to interpret the documents of paragraph 1 to pick up the characteristics of the nerve impulse, and part 2 to calculate the speed, and part 3 to determine the factor. Let's start step by step. First one, I interpret for document B only. So after applying a stimulation of the nerve fiber, we have 3 action potentials of the same amplitude was recorded by the 3 oscilloscopes. What does this indicate? This indicates that in the nerve fiber, the nerve message is conducted with constant amplitude. So the amplitude is the same of the action potential. All of them, they have the same. Here, velocity equal distance over time. So it's 10 to the power minus 2 over 10 to the power minus 3. So it's equal 10 meter per second. 10 to the power minus 2. Why? Because we have it as 1 centimeter. 10 to the power minus 3, since we have it as 1 millisecond. This is 10 to the power minus 2. You can write it over 10 to the power minus 3. So here, 10 to the power minus 3 meter, minus 2 meters, sorry, and 10 to the power minus 3 seconds. So it's equal to 10 meter per second. How did I get 10 to the power minus 2? Since we have it 1 centimeter. So I convert it into meter, it's 10 to the power minus 2 meter. And then if you want to move to the second, so it's 1 millisecond. So it's equal to 10 to the power minus 3 seconds. This one you have to know them. Okay? Moving to the third part, talking about the myelinated nerve fiber and so on. So for myelinated nerve fibers, at the diameter of the nerve fiber, this is the one in the table here. They want part 3, determine the factors. This one in the table of document D. Okay? So they said that as the myelinated nerve fibers. So the diameter of fiber decreases from 13 to 3. What happens? The average speed, it decreased from about 75 to 11 meter per second. So it decreased by about 6 times, let's say, or 7 times approximately. So this indicates that the average speed is directly proportional to the diameter. So as diameter increases, the speed of propagation increases. As diameter decreases, the speed of propagation it decreases. For nerve fibers having the same diameter, 3 micrometer, the average speed and the myelinated or non-myelinated, pay attention here. They have the same nerve fiber. They have 3 myelinated and non-myelinated nerve fibers. What will happen? First of all, if they have the average speed of the message of the nervous message for sure, and myelinated fiber is 11 meter per second, which decreases to 2 meter per second in the non-myelinated. So the second factor is the myelin. Already we know this. We have the myelin, we have the diameter, and also we have the temperature. If you remember, as the temperature increases, we have it as a note here. So this indicates that myelin accelerates the propagation of the nervous message. So this is the second factor. So we have the first factor, the diameter. So as the diameter increases, the speed of propagation of the nervous message increases, and vice versa. As the diameter decreases, the propagation of the nervous message will decrease too. For the myelin has an important role, important function in acceleration of the nervous message, meaning that accelerate, make it faster. So this is in physics. Accelerate, it makes it faster. So accelerate the nervous message propagation. So these are the two factors in this activity. Also to deduce here, two factors that affect the speed, they are the myelin and the diameter. As a note, please keep it in your mind. Also, we have temperature. Already we talked about this. So as the temperature increases, the speed of propagation of the nervous message increases. So if you want, you can add the 3 factors. But in this activity, in this document D, they are talking about only 2 factors, the diameter and about the myelin. But here we have also temperature. So here we have myelin, this is the first factor that affects presence of myelin. It leads the message to move in a saltatory movement. If you remember, here we have the myelin shaft, and we have the space between them. Who remember what do we call the spaces or the gaps between the myelin shaft? What do we call it? Let's see. What do we call the spaces or the gaps? Selena, what do you think? What do we call the gaps between the myelin here? The gaps
Note of
between.
Ranvier.
Very good. Nodes of Ranvier. So these are the nodes of Ranvier. So the message is going to jump here. Thank you, Selena. It's going to jump in a saltatory movement. So this jumping will accelerate the nervous message. So this is the myelin first factor. The second factor was the diameter. If we have 2 fibers, this is the first one, and this is the second one. The larger diameter, it have a higher speed or the faster propagation of the nervous message. Third one is the temperature. So as the temperature increases, the speed of propagation, the speed it increases. So the speed of propagation of the nervous message increases too. This is related to the propagation of the nervous message. So here we have 3 important factors, but in this document D, they are talking about only 2 factors. Okay, so here let's move to talk about this document. I want to move to document 2. Document E2, sorry. This is document E, part 2. So upon the stimulation, when the distance was 15 millimeter between S2 and R1, so we have only one action potential, only one peak. This is referred as a peak. So this is one peak is recorded. Why? When it came from 15 to 110, so we have 2 peaks with different amplitude here. So here, maybe it's referred to as presence of myelin or the absence of myelin. Maybe it's referred to as the larger or smaller diameters of the nerve fibers. So in this part is part number 5. So part number 5, part 4, I don't need it because already we talk about this a lot, and we're going to talk about this in the coming sessions. So propose an explanation to the variation observed between the different traces in document E2. So till now we solved part 1, part 2, 3, 4 we didn't, we skipped 4 and moved to 5. Okay, so 5, when the distance between S2 and R1, the stimulating electrode 2 and the R1 recording electrode is 15 millimeter, and after applying a stimulation, an action potential is recorded. As the distance increased from 15 to 110 between S2 and the R1, and after applying a stimulation, we have two action potential were recorded, and these are of different peaks. So we have two peaks. Okay, the first is recorded after 3 milliseconds of the stimulation. So here we have the stimulation after we increase the speed. After we increase the distance, sorry, the distance here increased to 110. But the first one was recorded here after 3 milliseconds, and the second is recorded here about after 6 milliseconds of the stimulation. Stimulation is recorded at time 0. So here, what can we say? So the nervous message is conducted at two different speeds. The first one after 3 milliseconds, and the second after about 6 milliseconds. So this means that this nerve contains two different types or two different kinds of the nerve fibers. Maybe the first kind is myelinated, or having a large diameter, and the second maybe it's non-myelinated or having small diameter, or maybe having small diameter and non-myelinated axon, and this will lead to the conduction of the nervous message in a slower manner. So what I want from you to know here, that the propagation of the nervous message is conducted, or it's depending on the presence of the large diameter and the presence of the myelin, which lead to the increase in the speed of propagation of the nervous message. While small diameter, decreasing this diameter, and the absence of myelin, it leads to the deceleration, meaning that the speed of propagation of the nervous message will decelerate, will decrease, and this leads to the message to be slower. So here, as the distance increases here the speed, the nervous message was recorded after about less than 1 millisecond here in 15. So it was recorded after less than 1 millisecond, which is recorded here. While when we increase the distance between the stimulating electrode and the recording one, it was recorded to 3 and after 6 with two different peaks. This means that this nerve, it contains the two different types of nerve fibers. Some of them, they are myelinated and having large diameter, or having large diameter and / or. So it depends here. Or the second one, the second probability that the second one, that the nerve fiber, they contain low number of myelinated nerve fibers as well as the small diameter. So here you have to pay attention to these notes, recording the diameter and regarding the myelination, the presence of myelin or the absence of myelin. So what I want from you to remember about this and to review it for the next week. So you have to review these sessions for sure. And what I want from you is to pay attention to the differences between the propagation and the nervous message between the nerve and the nerve fiber. Who can give me a hint talking about the differences between the nerve and the nerve fiber regarding the conduction of the nervous message? Who can give me a hint about this? What is the differences? Yes, Muhammad.
The nerve fiber obeys the law of all or none.
Propagation of the nervous message in the nerve fiber, it obeys the law of all or none. What the meaning of this, Ya Hassan? What the meaning of obeys the law of all or none? Thank you, Muhammad. Professor Hassan Watfa, what the difference between what the meaning of propagation obeys the law of all or none? What do you think? Hassan, hello, it's me. Yes. What the meaning of obeys the law of all or none? That's one that you don't have to study that. These are no important notes. There are not important notes. شو ادرسهم؟ مش مهمين هيدول. هيك؟ So these are the notes. اللي قلت لي ما هيدول ما بيجوا بالامتحان. So what do you think, Hadil? What the meaning of law of all or none? What the meaning of the law of all or none? What do you think about this, Hadil? Obeys the law of all or none? Let's see if you studied the notes before or not. Obeys the law of all or none. Hadil, can you hear me? Hadil, good morning. I think she had a problem in connection, I think. So I'm going to explain this, Hassan Watfa, and pay attention to this. These are the notes. You don't have to study them. These notes, they are not important. صح? So these notes obeys the law of all or none, meaning that either we have an action potential or we don't. Not the case in here. Here we have half action potential and an action potential of different amplitudes. The law of all or none, either we have action potentials of the same amplitude or we don't have an action potential at all. This is the law of all or none that's found inside the nerve fiber. So the nerve fiber, it obeys the law of all or none. Why the nerve? It doesn't obey this law. So you have to pay attention to this. So these notes, you have to copy them on your copybook. And this experiment, the document, the part 5 of the probing the documents, they are very important. So next week, we're going to continue with the 6 and 7. We're going to complete these and also to talk about documents F and G about the propagation of the nervous message. And we're going to move to the document 4, talking about the sensory receptors and the nerve impulses as well.